let's go over your triads. So we are writing the fractions as decimals. So the top number goes on the inside, and on the outside is the 5. And so 5 goes into 6 one time. 1 times 5 is 5. Subtract, and you get 1. Because that's not 0, we're going to add a decimal, and we're going to add a decimal above. And then we follow that with a 0, and then we bring that down. So now we have 10. 5 goes into 10 2 times. 2 times 5 is 10. When we subtract that, we get 0. So my answer is 1.2, or 1 2/10. So that's a terminating decimal because it has an ending. It means we have a remainder of 0 when we do long division. So now we need to turn this one into a mixed number. So we multiply 8 times 7, and then we add 3. 8 times 7 is 56, plus 3 is 59. So this fraction is equal to negative 59 over 8. So now we know that 59 goes inside and 8 goes on the outside. 8 goes into 5 0 times, but 8 goes into 59 7 times. 7 times 8 is 56. When I subtract, I get 3. Since that's not a 0, I'm going to add a decimal and a decimal above. I follow my decimal with a 0, and I bring that down. So now I have a 30. 8 goes into 30 3 times. 3 times 8 is 24. When I subtract, I'm going to have to borrow, so I'm going to take away that 3. Now that's a 2, and I add that to my 0 in front of my 0. So now I have 10. 10 minus 4 is 6. 2 minus 2 is 0. That's still not a 0 yet, so we're going to add another 0 and bring it down. 8 goes into 60 7 times. Yep, 7 times. 7 times 8 is 56. I'm going to borrow. So that turns to a 5, and now we have 10. 10 minus 6 is 4. 5 minus 5 is 0. Add another 0 because we don't see a pattern yet. And I'm going to bring that all the way down. So 8 goes into 40 5 times. 5 times 8 is 40. When I subtract, I get 0. So this was another terminating decimal. So my answer to this one, remember this negative here means my decimal is going to be negative. And then it's 7 375 thousandths. All right, the fourth one. So 3 goes on the inside because it's the top number, and I'm dividing that by 11. 11 does not go into 3, so I need to add a decimal, and I add a decimal above. And I follow that with a 0. 11 goes into 30 2 times. 2 times 11 is 22. When I subtract that, I get 8. 11 goes into 8 0 times, so I need to add another 0, and I'm going to bring that one down. 11 goes into 8 7 times. Let me extend this over. 7 times 11 is 77. Subtract. 10 minus 7 is 3. 7 minus 7 is 0. Still not a 0 yet, and I don't see a pattern yet. So I'm going to add another 0 and bring that down. 11 goes into 30 2 times, now I'm starting to see that pattern. 2 times 11 is 22. When I subtract that, I get 8. Oh, we've had this before, but let's just do one more 0. And so 11 goes into 87 times. That gives me 77, because 7 times 11 gives me 77. And when I subtract, I get a 3 again. So you'll see that my pattern started happening. And so we can take this decimal, and remember a 0 goes in front of our decimal if we don't have a number there. So 3/11, well, negative 3/11 is equal to negative 0.27. And then we have to make sure that we add that bar above it, because if we don't add the bar above the 2 and the 7, then it's not the same thing. This bar being above the 2 and the 7 tells us that the 2 and the 7 keep repeating. If I didn't put the bar above the 2, then that's saying that only the 7 went on forever. And that's not true. Our 2 is repeating as well. So we have to make sure that it goes over both of those. All right, last one for the triads. So we need to multiply these two and add it to our numerator. So 27 times 1 is 27, plus 5 is 32, and then we keep our denominator the same. So now 32 goes on the inside, divided by 27. 27 goes into 32 one time. 1 times 27 is 27. I'm going to subtract that. When I subtract that, I'm going to have to borrow. 12 minus 7 is 5. 2 minus 2 is 0. So that's not 0 yet, and I don't have a pattern yet, so I'm going to add a decimal and a decimal above, and I'm going to add a 0 and bring that down. 27 goes into 50 only one time. 1 times 27 is 27. When I subtract, I need to borrow. 10 minus 7 is 3. 4 minus 2 is 23. Or sorry, 2, and then that turned into 23. So then now 27 doesn't go into 23. So again, I have to bring down a 0. And 27 goes into 230 8 times. So 8 times 27 is 216. If you didn't know that, you could have added 27 onto the side multiple times and then gotten all the way down to see how close you could get to 230. Or you can multiply 27 times a few numbers and see what gets you close. So 8 times 7 is 56. 8 times 2 is 16. Plus 5 gives us 21. And so that's where I got that 216. So now I subtract these two. I have to borrow again. 10 minus 6 is 4. 3 minus 1 is, nope, sorry, that's a 2. 2 minus 1 is 1. So I have 14. 7 does not go into 14, so I'm going to add a 0 and bring that down. 27 goes into 140 5 times. And so 27 times 5, 7 times 5 is 35. And then 5 times 2 is 10, plus 3 is 13. So we have 135 times. When I subtract that, I get 5. And we've actually already had this part, so we bring this down. And we get 50 again, and we already had a 50 up here. And now we have it again down here. So that 27 goes into 50 one time. And so now you'll see that this is starting to repeat. because this 1 is starting over again. Because then we get, that's 27, we subtract, and we get 23, and then that leads us to this section here. So this 185 is going to repeat forever and ever and ever. So my answer, and I ran out of room, is 1 and 185 thousandths, but that actually repeats. That goes on forever and ever and ever. So it's actually not 185 thousandths. This is repeating. So it actually goes 1.8. Oh, no, there we go. 1.185, 185, 185, 185. So that 185 is repeating, so that's what repeats. I can't draw the line over the 1. It has to always go after the decimal.